So let's go to Q&A. Let me go to Jeremiah first. Jeremiah, go for it, sir.
Could I interrupt just for a second?
Oh, sure.
If you want, I'll answer anything you want. Go to our website, QED-NE.
Oh, yeah.
And that has 5 papers that I've written about a variety of subjects, and also images, all kinds of great information that we've been able to compile. It's brand new. I think it's very modern looking, and I think you would all probably enjoy it.
Yeah.
Okay. Sorry.
Well, actually, yeah, no, that's a good point. So anyone who's looking to support your work, anyone who wants to learn more about it, it's QED-NE.com, and they can contact you through that as well, right?
Yeah. QED-NE.
Okay. Yeah, because I know that you guys are looking for supporters and looking for people to get engaged and learn more about it. So we'll put links in the show info as well to that.
Okay. Thank you.
Okay. So let me go to Jeremiah now.
I thought that man, besides that just being absolutely fantastic, and I'm overjoyed that you're finally coming on and not only talking about it, but showing what your actual drives look like, getting up close and detailed, giving the theory, giving the disclosure. I was so hoping today that you were going to do it. I was so hoping you were actually going to come out with that information. But what I really wanted to ask, and what you didn't talk about, was the nonlinearity response to the drive for the same power input over time. And I was wondering if you could touch on, the output or thrust observed from the drive over a period of time that it runs with the same exact power input.
Well,
have you noticed it?
It's a cumulative. So it deployed to space, it would accelerate continuously, just like an ion drive would, but the fabric of space would continue to compress with a constant power level if you wanted to operate that way. We've tested in a pulse mode, thinking of conserving batteries or solar panels input. It works on constant power. Like I said, it's a cooling feature. It's almost like a Peltier diode in a way, where the fields cross over. That's what we've observed. But, here's a little bit, I usually don't talk about it because it's all of you, all right, very specialized and interested in stuff of anti-gravity.
Well, if I could jump in really quick though, I don't want you, I know that you guys have a lot of proprietary material. I don't want you to share anything proprietary, right?
I haven't given you, even though you may think that I've given you a lot, there are many trade secrets and company proprietary information that I don't disclose, and that would never disclose.
No, and that's perfect. I just wanted to stop you before, I don't want you to share anything that you feel uncomfortable sharing, I guess.
No. I mean,
but you already showed us your system, your filing system. I mean, I went to science information technology, and they teach you about databasing and SQL and stuff like that. I mean, you already put that information. I could search this and retrieve it back, because it's already there. So everybody has to take an oath that you share it for good, really for good.
There, we'll do the Scouts oath.
Yeah.
There.
Oh, really? I mean, I'm beyond serious. This is
very
important.
Yeah, no, I think what he's saying is he has a lot of other scientific data and in-depth analysis and stuff that, and again, that's perfectly fine. I know that that's an area that you guys are sensitive about. So I just didn't want to.
For me, listen, I was going for cybersecurity. So it was
believe me, I would not disclose anything that I wasn't comfortable disclosing. Now,
so for me, find some kind of, I think is a breach of some kind of thing. It's just in my nature, I have to, because that was the thing that I chose, to close the gaps in.
Wonderful.
So.
Oh, well, thank you, Lulu.
Let me
go back
finish
to
up,
Jeremiah, and my
right.
apologies.
Let me finish up with his question. I'll let you in on a little thing that we found. I haven't spent a lot of time researching this, but when you turn the motor off, drive motor, there's different definitions. The VEM drive. When you turn it off, it still moves.
Yeah,
For close-
absolutely. And that's specifically what I wanted you to talk about. The reason why I wanted you to talk about it, and I know you don't want to talk about this because it's one of those things that currently you think is a really deep dark secret, and it's one of the great discoveries that you haven't heard priorly talked about. But I did some deep digging, and it turns out there's actually 9 other drives that also show the same exact thing. And so, because you put in so much work and so much effort, and because you have a functional version of a device that can be demonstrated today, right now, you're in a position to basically, they're going to come out and talk about their wave bands, talk about all that information too. So why let somebody who put in less work be the first to talk about that when realistically you're already on top and you could be positioned perfectly to be recognized and credited for what you've already discovered? Because otherwise they're going to start talking, and they're already talking.
Yeah, I would say with lifters, we saw the same thing. It's interesting that you mentioned that, David. We did see that. I saw the same thing. It's a horrible way to describe it, but I almost felt like it was conditioning space. You know, the effects are not. Yeah, it's not tied to the power on off, and in our case, like, we didn't see anything like what you have, right? With the far more rudimentary, but we did see some weird stuff, and it wasn't directly tied to the on off. It felt like there was a space itself was changing a little bit. So,
You know, the other interesting piece of this and the development of the VEM drive is that it comes from a natural occurrence in nature. Antimatter, thunderstorms, the evolution of this particular situation of non-sustainable local space warp bubbles and these aircraft that went through, these airmen that went through this. And we have their testimony and we've got their data. Most scientists ignored these people and said, like on these typical TV programs, that the guy's crazy. Or you have Michio Kaku criticizing, calling Bruce Gernon.
David, I just had that a second ago. I went out to Sonny White and told him, listen, David Perez is working on this right now. He's got results. Come and check it out. And he totally blew me off. Said, no, I'm going to go to this other conference room. And he didn't even go there. He was just trying to get rid of me.
Well, that's
the mainstream is not interested in listening to this.
No, they're not.
They're totally. I just experienced it 2 minutes ago, and I could take my laptop over there and watch, literally chase him. He'll run away from me. He's like, they're just not interested in this.
Well, here's the other part. We know the government's been watching us. That's why we have the website. That's why we do these things. So we just let them know this is exactly what we're doing. I find it's easier to hide in public than it is to, hide in my lab and then have them pull up in their, black SUVs. We have had a break-in that was like over 2 years ago, and they did steal some of our parts and they damaged our system. It took 3 months to bring the whole thing back up online, but they broke in. It was very touchy on how we figured out that they did break in. See, I always have the power turned off in the lab. I don't want to end up like Nikola Tesla with his lab burning down. So there's no power in the lab at all. So when I leave, that switch, boom, it's gone. Well, I come into the lab and the lights are on. And I'm going, what is going on here? I'm looking around. I can't see anything missing. And then from the day prior, we were going to do a live stream to lift a motor to demonstrate. Well, guess what? System doesn't work. It's like a short somewhere. We're checking it out. And then I noticed that one of our motors is missing that we have, but we have 18 of these things. It's kind of hard to keep track of all this pieces and parts that you got hanging around. And then I noticed the one I had hanging up on over the workbench was missing. And then I looked and some of our fractals were gone. I knew exactly how many fractals were sitting on the bench. There were 16. 2 of them were missing, and 2 of the associated plastic plates that we put them in were missing. Now we 3D print our motors now. So, we've cut down on weight. We've gone from 10 pounds down to less, actually to 1 pound. And the way I'm looking at this, the lighter I can get the apparatus and the more efficiency that I got, less power, more compression of the fabric of space. then the more dramatic, more than 4 millimeters of lift on the motors right now, but it's lifting itself plus the harness. I mean, it's there. But no one wants to believe it. They only will believe
It's like,
it.
it's like
if I can-
Galileo, that they refuse to even look through the telescope. And here it is in real life. They're refusing to walk 150 feet and come and check out APEC and see actual results. They'll rather push you off and run away.
Right.
Yeah, well, you know, David, I should mention, we have a number of people in the conference, and I am not one of them, but Mark is very deep into 3D printing. And I believe Thomas, who was on earlier, I think he's still with us. So that might be an area that people could contribute as well. You know,
We also have a large 4-axis CNC machine, and I've been cutting lots
Oh.
of copper sheet. Yeah, we can cut you some stuff if you like. I've actually done that for Todd Desiato over here, and he just sent me the diagram, and I cut some aluminum stuff for him and shipped it over.
Yeah, we have to go out to get that done. We outsource. And
Yeah,
Yeah,
well,
so we could take care of that. We have up to, I think, 30 by 20 by 16 inches is what we can cut.
wow,
yeah,
very
so that,
nice.
I just thought I'd mention that because yeah, Mark is really active, you know, and Jeremiah is active also, although he lives kind of a different part. So I think Mark is the person with the big lab, but then, you know, again, we have other folks like Thomas who are doing a lot. And like, I'm not sure if you heard earlier, they were talking about material science stuff. So they're,
Yes, I
Yeah.
heard that.
yeah, there's a lot going on here. And what I found is folks are pretty willing to just help and contribute and stuff like that. So, and it looks like,
But Jeremiah's holding up.
yeah, so I think Jeremiah is already,
Oh, into some fractals there.
yeah. Well, again, I think he's been greatly inspired by your work. He's been talking about it for like 9 months. So
I've been watching QED since QED started producing videos. And then I watch those videos disappear. And then I watch the new ones pop up, and then I watch those ones disappear. And you go through the process of realizing that you come across something that you maybe were a little open about at first and thought was much more. Well, the thing is, it was exclusive because nobody was talking about what they were seeing. It was just too weird. And now finally, they're all coming out of the woodwork. The gateway has been opened. Pandora's box will not be closed. And
Well, we have a
we're the
couple.
demons that are coming out that that
Go
the
ahead.
others are afraid of. So
yeah. Well, let me go to Michael Boyd. Michael had a question. Michael, go for it, sir.
So Dave, I'm curious, you know what a lightning sprite is?
Yeah.
And you know what an elv is? An elf, it's the one that's like a circle and it's up at 50,000 feet.
Oh, yeah, okay.
Okay. Would you consider those both forms of positive lightning? By positive, I mean it's a positive charge as opposed to a negative charge, like from the Earth to from the bottom layer down to the Earth. That's a negative charge.
Well, actually, the lightning down to the Earth
Can be positive too.
is positive, actually.
Oh, it is.
Yeah, the current flow out of the clouds go positive to ground positive. So positive out to ground, then up. So negative from the ground up to the base of the thunderstorm. And which is
That's my understanding too.
right.
So my question is so in your experiment, did you see any coronal discharge?
No coronal discharge at all.
Interesting. So
Now-
that's my question. I'm just curious
Yeah.
about.
Now,
those
the
effects.
fields that we produced, that we actually mapped the signature, the warp signature, which I believe is a first, took us a long time to develop the code, to analyze it, to manipulate the code, to collect the matrix of data and then produce an image. Kyle Finley, he does all of that for us. And we have an engineer, Jim, he's our double E, and I put out the specifications for the equipment. I help assembly, I build the motors, I design the motors, and everybody's delegated different responsibilities in the organization. There's about, and we have people dripped in and out, but we have about 8 people in the group, 4 highly active people. We meet, and when we're doing experiments, everybody's there and collecting the information and whatnot. But to answer your question, the sprites and blue jets that come up from the tops of thunderstorms, since it's a positive current that comes out of the top of the thunderstorm, I could only assume that it's a positive energy that comes up out from the thunderstorm.
So like anti-gravitational as opposed to gravitational. It's repulsive.
You know, in that
Repulsive force.
context, in that context in the atmosphere, I don't have any data to support that.
You just know it's electrostatically positive.
Yes, that's correct.
Okay, well, I appreciate
It's a lot of it's a lot of energy.
Observe any of that in your experiment, which I thought which is probably how you can make it coherent, where you're actually getting that time or that, I guess, what is actually changing? Is it space?
Yes.
It's
Yeah,
the actual. It's
Real-
kind of like expanded space time. So Hal
Well-
Puthoff described it as he calls it anti-gravitational, or it's actually the length dilates.
Well, the compression of the fabric of space is what we're dealing with here in our space time.
Oh,
So
the other
what
way.
we're actually doing is forcing local space and to compress it and form a bubble, and in this case around the engine. So if you go to the website and you see some of the imagery that we have there, the graphics, you'll see the base plate expanding out and the top plate expanding in, the compression of the fabric of space expanding or compressing into the motor.
Gotcha. Okay, well, thank you for answering my questions. I appreciate it.
Now, David, I have a quick question actually, and I'm not sure if this is something that you guys have looked at or not, but I'm really intrigued by when you looked at the aircraft and the flight times and things like that. Oh, sorry about that. So, because you're talking about the Dragon's Triangle and the Bermuda Triangle, did you guys look at the ships at all? Right, that's been the long-term ongoing mystery. I know planes are a big part of that, but
I have, and I've gotten several emails from guys who sail yachts that got displaced. There are many accounts in the Bermuda Triangle. I've actually flown in the Bermuda Triangle collecting data. And you got to remember also, this is not a phenomena that's isolated to one part of the earth. When the weather forensics have shown these parameters, and I figured all that out, in between a high and low pressure system, the zone of transitions, when you get a lot of convective activity coming up, and this can happen all over the world. If you have solar winds that are over 700 kilometers per second, this is a good time for this actual phenomena to occur on Earth. In my particular case, when I did the weather forensics and I analyzed 26 aircraft after out of 50 plus aircraft that disappeared, I found a commonality of the investigating the weather forensics. So onshore flow, dew point to ambient air temperature less than 6 degrees. All these characteristics start the thunderstorm activity into the Key West, and then it flows up towards 20 degrees north latitude. And this is also involved with the trans-equatorial propagation of electrons that occur up and past 20 degrees north and south latitude. So this energetic atmosphere on the strong side of the sun, this occurs every day. But when you get these other characteristics from space down and from ground up, this is the ideal time. And it appears that early December, because this flight that this Tiger Moth took was in the late fall. I didn't have an exact date, but they indicated it was late fall that they were flying. And this all could correspond to being able to predict when this can occur in an aircraft fly through. My problem was, okay, if I can pre-predict this, fly an aircraft through, and then this thing does a linear displacement, depending upon which way I'm pointed, I could run out of fuel or I could get to land. In Bruce's case, he was fortunate that he was headed east to west. If he was going the other direction and encountered this, he'd be out in the middle of the Atlantic. He would have never had enough fuel to get back.
Well,
And-
it sounds like you could use the analysis and the technology. You could also use this to develop kind of an early warning system, right? Something you could put in an aircraft or a ship to help improve safety.
To detect the warp bubble, we haven't done that yet. We only produce warp bubbles. But from the weather standpoint, from relating the parameters of weather to look out and beware, yes, we could do that. We could come up with a weather forecast for warp bubbles. They don't occur very often, but the thing is that we could produce a early warning system for pilots beware in these regions. I don't know if anybody would accept the parameters, but anyway, we could make an attempt to do that.
Yeah, no, that's intriguing. Well, let me go to Wayne next, and I should ask how you're doing on. So we're around 3:30 now. We have about half an hour left in the Q&A session. I should ask if you're doing okay or if you need a break or anything like that.
I'm good.
Okay. Just wanted to
Hey,
double check.
I teach 4.5-hour classes.
And
So
you go online too, right?
Yeah.
So,
I'm just getting warmed up here.
okay. Our 11-year-old did online school last year, so that was a learning experience. So my hat's off to you, sir, because that is not easy. But
No.
okay, well let me go to Wayne then. Wayne, go for it, sir.
Hey, that's fascinating. Very fascinating, your work there. I was wondering if you could comment more on the geometry of the so-called warp bubble. Like, is it a sphere, or does it kind of project in different kind of geometries through space? Or could you mention 140 centimeter distance between your torsion balance and this device?
And the motor. Yeah. We have different size engines. We have engines that are 6 inches, 13 inches, 2 feet engines. Those are our modern ones, our newer ones. There's been comments from people. We applied for an NSF grant. We got rejected and provided it took 3 months to put all this stuff together. And one of the reviewers said it's impossible, can't happen, even though we provided videos. And as you're saying about the warp bubble, we described what they would look like. And the warp signature mapping that we've done goes out to 7 inches. And it still has the same characteristics of going into the engine and coming out and expanding behind. So should I define this as kind of a circular or an actual bubble? That's more a description than it is reality. My experience so far has been that it's not, quote, a bubble, so to speak, but it's literally like taking a slinky and compressing it, but it going into the motor. And then as you look at that image that we produced with the undersheet, you can see where the outer top part starts to expand up and around. And that, I guess you might want to consider to be kind of a bubble. But I think in the symmetry of it is that it's not really going to come out to be a, sphere, like a
Right.
bubble, a bubble that kids would play with, with the soap bubble. Not going to look like that. It's actually going to be more definitive depending upon the engine that you use and the amount of power All of that will be adjusted. At least that's how I'm predicting it. I mean, the experience I have right now shows that that's exactly what will happen. Now, maybe at a higher level of energy, we may get something totally different, but I kind of suspect that it's going to maintain a signature like we've produced already. If it's that way at 10 watts, it'll be that way at 10,000 watts as well, if not bigger.
Yeah, and correct me if I'm wrong, but it has to do with the wave fronts of the radiation coming off those antennas and how they collide with each other and create like a superposition. So you
The
get
near fields.
like a crossover of the two different amplitudes of
Yes,
of the energy.
yes, the near
So
fields.
that doesn't imply necessarily the formation of a sphere or a bubble. So yeah.
That's correct. However, as you look at that image, you see where it curves out and around.
Okay.
So there's an influence to the exterior space, which ties into Alcubierre. So I would classify this as an Alcubierre based warp drive. I'm using the term warp drive because we couldn't get our papers published unless we changed our terminology to variable electromagnetic drive. And because Sonny White had gotten his paper published by the AIAA, which there's been a lot of criticism of, I'll just mention, we couldn't get our paper published until we went the realm of variable electromagnetic drive. And once we did that, the correspondence principle was in force. We're not going outside, you know, the legions of science, and you must conform. Hey, look, we think outside the box. This whole thing was outside the box. And as far as we know right now, we don't violate any of the accepted physics laws, except I damn well intend to go faster than light. And once we can get this out in space and we can encourage miners to actually engage these engines, purchase them to get to point A and B to make the turnaround, that's where the next revolution of our economy is going to, it's not here on the earth, it's out there, becoming a spacefaring nation. And I am so tired of all the talk, and NASA pushing off their projections to go to space. You got Elon Musk trying to get to Mars, and it's going to take him, he says, 7 months. But the astronauts, whoever's inside these craft, are going to get overly exposed to the radiation. They're going to be dead or nearly dead by the time they get there. They're going to experience over 300 rads of radiation. At 125, you're puking your guts out and you're red all over like you've been exposed to the sun. The engine that we have today, the estimates that I made with the constant acceleration, we could get there less than 45 days. That cuts the exposure down to a minimum. That means you could get there, you could come back. However, all the emails, all the papers that we've tried to send him behind the scenes, it's fallen on deaf ears. And so, you know, that's what we live with.
Or were you sending it to Sony White papers?
No.
Oh, to the AIA?
AIA, we published the paper for the 2018 conference in Cincinnati, and we presented there, and the room was packed. They didn't have any of these little side discussions that had as many people as we had. But then afterward, everybody left. And, you know, that's
Nothing happened.
You could hear a cricket.
That's the main, that's
We
the
have
mainstream.
we have an experiment coming up using standing waves on a basically a round plate, and trying to get some interactions with that. Why were you using fractal antennas instead of just regular dipoles or plates?
Being the ham radio operator that I am, I don't like buying anybody's stuff. I build my own. And I had heard about fractals. There was a professor at MIT. Actually, the company name is Fractal Incorporated, I believe. Anyway, he was restricted to an apartment that didn't allow him to build antennas and hang them outside. So we got this idea, hey, what if I built a fractal, put it up on the window? And what he discovered was that the fractal, so long as you keep the a wave characteristic, in other words, say you're doing 150 megahertz, okay? And the antenna is tuned and it's like over 3 feet to equate to 150 megahertz. But you can take fractional pieces of that. And what he found out with the fractal analysis or his fractal antenna is that he could have the same amount of gain as a full size heavy antenna. And so taking that idea and incorporating that, I had a real problem, despite the fact that I figured out how these pilots got a linear displacement. How could I reenact this, artificially create this? Do I create 2 huge radio antennas and then sail an airplane through it at, hundreds of thousands of watts of power to create that scenario and poof, let them go out? And the only way to achieve this and to miniaturize it was to look at fractal technology and to use fractional wavelengths of the frequency that I was using, which is emulating a thunderstorm. Does that answer your question?
Pretty much. I just wanted to say that if you need any fractal antennas made, we'd be glad to help you out in our lab. We have lots of copper, aluminum, steel, all different materials. I could CNC it out and ship it out to you.
Okay.
Anything that can move this technology forward, would be glad to help.
Yeah, and the other thing I always need to mention is that in one of the declining of this technology from NSF was that they didn't believe this could be scalable. Well, we've scaled it from 6 inches up to 2 feet, and I've gotten results on every engine that we have produced. So apparently they didn't read, they got paid to do this analysis of our proposal. And this is the kind of people that we got at NSF. I mean, maybe they've done some great stuff, but we laid it all out. But that's why I won't patent this thing. The patent pending is to put our placement of intellectual property. If you patent stuff, the US government can come in and take it. And they don't have to pay you. They'll declare national security, and that's the end of that. So that's why even talking to Harold Puthoff, which I've had discussions on the phone with him, in the past, he said they don't patent anything because of the fear of the government coming in and taking it.
Yeah. Let me go to Thomas Anderson next, because and again, Thomas does a lot of material stuff as well, so he's a good person to ask. Thomas, go for it, sir.
Yeah, can you hear me?
Yeah.
Okay. I was going to say that was my question, was like, what materials are acceptable materials for the fractal antenna? Like as far as the conductive part, like could you use graphene foam for it?
We've not tried that. Our standard is copper. We've done solid state etching on circuit boards with our patterns. We've CNC'd out the fractals. We have used solder, and we have produced solid state arrays. This last motor was aluminum.
Actually, I just realized if the graphene foam doesn't work, because the reason I thought of that was that you can use a very cheap laser engraver to do really tiny controlled fractals using Captain tape, and it turns it into the graphene foam. I made the mistake of basically trying to use a what do you call it, electrolysis process to speed up removing aluminum using copper acetate, and I ended up plating the graphite with the copper. So that means that if you connect to the end of the fractal array and put it in like a solution of copper acetate and using the copper electrode on the other end, you should be able to plate the whole thing just where the graphene is formation is formed. And because it's a foam, it should infiltrate the graphene too. So it's not graphene and then a layer of copper, but rather you end up with this fluffed up graphene that is filled up as well as a coating of copper across the top. So,
Well, we're very interested in solid state copper arrays at this juncture. The less we found through experimentation, and I don't know, one person mentioned, why cut somebody else's progress, but it doesn't take long to figure this one out. Solder crystallizes with these arrays.
especially
And-
with bismuth in it.
And what we had to do was about every, 50, 60 runs, we'd have to strip all the solder off and redo everything. So that's why we went to solid state. Our solid state circuit boards work fine. However, the thickness of the copper clad was not enough as we went up in wattage. We'd blow fractals right off those things and cause a lot more additional work. But look, this is 10 years in progress. So of course we know a lot more stuff than somebody else is starting out. We've had people ask us, can you send us plans and diagrams? And I'm going, are you out of your mind? I'm going to turn over everything I know about this thing just so you can experiment. I don't think so. Would you go to Boeing or Lockheed to do the same thing?
Right. So, well, I mean, the economy thing was mentioned earlier, and it's like, I don't think people realize that the only way to go to a moneyless society is to make people stop counting, period. No numbers, period. Because we use that as a tallying method for, and my understanding is it's a tallying of ideas to direct, energy to do the work, and materials to create. So that's your money. So you're counting that, and then you tally that up. And of course there are people, who do a bunch of misdirection in order to basically be like stage alchemists, like a stage magician, where it's not real magic, it's just sleight of hand to turn paper into gold and whatnot. But the concept is still solid. Just because somebody is using people's ignorance to basically rip them off using that concept,
Right.
doesn't mean that the concept itself is bad. Just like, you can use a gun to fire something to cut through material in order to make something, just as easily as you could go out and use it to like extort something from another country. So it's all, who's using it and what's their intent, and how do the other people feel about how it's being used against them. So, but yeah, I have experimented with that, just using a 50 milliwatt UV laser to make conductive foam, and the conduction's actually pretty good. I mean, 10 centimeter squared, it's like between 0.2 and 0.5 ohm. So, and I would think that the carbon would be more durable because of the fact that the graphene layers themselves are actually stronger than diamond, and the heat levels that you can hit with that, as long as it's not oxidizing. If you're in an oxide environment, you can't do this, but in a non-oxidizing environment, you can hit almost 5,000 degrees before it finally melts.
Huh?
So, but I mean, I wasn't sure if there were other properties about what you're using for it that are necessary that this would not have, and therefore it wouldn't just, wouldn't be usable for it. Just like bismuth has a diamagnetic property and steel doesn't. So if you're trying to build something that needs a diamagnetic property, the steel is not going to do you any good.
Right. And that's why our material science investigations has been limited because of the cost involved in getting these things produced, buying the copper, buying the aluminum. Everything's gone up in price very substantially. And so we haven't explored that, except it's a small team. Here's my problem. All the various techniques that could be incorporated into this motor are great. My goal is, and my focus is, to get this damn thing off the ground, 10 feet, 20 feet off the ground. And at that point, nobody can complain that this thing doesn't work. You know, right now they're still, you know, looky-looksies, looking at this thing. Oh, it only does 4 millimeters. Well, show me an ion drive engine that can do more. They can't.
Can I make a suggestion?
Yeah.
Change your goal to making it useful, because that seems to be the one way that stops all of the pushback where they say, oh, you're crazy, or that idea won't work, or we don't want to use that. Because the second they see you're going to get an advantage they're not going to have, they will come and do whatever they have to get that advantage too, and not be left behind. So if
Well,
they even think you're going to do it, it doesn't even matter if you honestly think you can get to that point because of the cost and everything. If it's put out there that you're going to be capable of doing that, they're going to be knocking your door down to try to work with you and do whatever they got to basically get your benefit, your capabilities, in order to basically make this thing a, you know, a worldwide available technology to change the economy. Like you said before, being able, like you said, you know, you were talking about miners and turning around and whatnot. And my thought is, if you have that capability, why mine like, you know, what most people would think of, oh, you're going to go mine asteroids, you're going to go to other planets and mine. There's nowhere near the amount of material in all of the planetoids, all of the asteroids, all of the Kuiper belt, everything else that's in our solar system than there is inside the sun. And you can use the very energy the sun has to pump that out as plasma and catch it. And it actually reduces the poisoning it does to the sun so that the sun will last longer. So.
Well, the reason why I mentioned about getting the altitude is that as a function of Burning Man, there's a art project that they want to do and lift it with a warp drive. And so my goal to getting it to 10 pounds. Hey, believe it or not, they got 70,000 people.
Oh.
And they got
But,
checkbooks.
I'm gonna say, if you
I will personally help you with that. If we're
if
going to a Burning Man with a warp drive, that will be disclosure.
Well, I was gonna say, if you want to see how much money and how
Yes.
crazy the people are that are behind all that, go look up Omega Mart, because it's the same people. It's the BlackRock Art Foundation that funded, and then it's like they said, hey, yeah, here's enough money, build a whole Walmart and just stock it full of you know, professional grade products that are, you know, you're gonna have to make them yourself, because it's like, you know, sodas that are like, you know, the flavor is new car smell, you know.
But
Now,
that's what one of our goals, one of our reasons to improve the motor weight of the motor, or to be able to lift more, is for that very project. It's a worthwhile goal. I've been told that it could be a year, 2 years off, but then again, I've been in this for 10 years, so I don't expect much patronizing from any aerospace company, anybody from NASA. We've actually sent an envoy out to NASA, to JPL, and no interest, despite the fact they had the videos and everything else. No interest at all.
Well, I think the reason you're not getting any interest there is because of tenure. Once people have gotten used to the concept of tenure, they really don't have any drive to do anything more than what they had to in order to get recognized and get into getting the tenure. So they're going to push back on anything that would challenge their position, you know.
That was the impression we got, was that we're working on soft money here, and we're not getting involved in anything that distracts from our livelihood. And that was pretty much the nail on the coffin right there, you know.
Yeah. So.
Well, let me go to Harold Tavares next. So Thomas, thank you again. And Harold, go for it, sir.
Great presentation. I like it a lot. But the idea that somebody broke into your lab is still in my mind. So I'm wondering, if you were to speculate, an educated guess, do you think was an aerospace company, a propulsion manufacturer, or some foreign country that may have broken into your lab, that may have some interest in gaining your technology, your know-how, so that they can themselves then put it out in the market? What is your educated guess?
We initially thought it was the government and one of the intelligence agencies or something. But then again, they know about us, and I've been told by people in the government that have contacted us that we're being watched. So I don't believe it was one of them. And if they were really that professional, they would have turned the lights off. Unless they wanted us to know they were there and they got our stuff. They broke lights in the back of the garage. They came in through the back and picked the locks because they're always locked. I don't know if you know people from New York. If you don't lock stuff, it's gone the next day. I'm a New Yorker, okay? I'm looking over my shoulder, everything. I'm Mr. Security. I got, but they did their job. And the other thing that really disturbed me was it wasn't so much taking the motor parts, because I don't care. If you took one of our motors and you tried to replicate the stuff, it ain't gonna work. You got to know all the other pieces and the parts. You got to know all the process that goes into it to make it work. And if you don't know that, you just wasted your time. We've had people try to replicate it and they get horrible results. Well, sorry, we're not giving that out. So as far as speculation goes, to answer your question, I really don't know. I honestly don't know. I suspected intelligence agencies, but they left the lights on, and that's a sign maybe they ought to get some new intelligence guys.
Oh, so do you think maybe it was a competitor then? Maybe it was a competitor, or like a crazed fan or something like that.
Yeah, it could be, but I'm here all the time.
Yeah.
And it was done late at night, I can tell you that. And I'm kind of a light sleeper as well. And I get up through the night. I got ideas. I write them down. I go to bed with problems, and I get a solution. I wake up, I'll write it down. So whoever it was, they were in between my sleep cycle, like, or I was deep in my sleep cycle, and they got by me. But,
yeah. Well, let me go to Jeremiah. And I think we're pushing up close to our time, but Jeremiah, go for it, sir. Oh,
Yeah, the reason I wanted to just put in one last question / comment here at the end before he goes off is, David, do you have any restrictive corporate, government, or other investment interests that would prevent you from working with private individuals in terms of funding?
no.
And even if that funding was small or something, I mean, would it help you guys out in a significant way, do you think? Putting every dollar to use?
Well, depending upon the amount of funding, would make a huge technological jump. Right now, I self-fund everything. That's why I work 5 jobs.
You've got a great outlet right now to basically let people know that you're open to receiving donation-based funding in order to further this research with the reward of teaching the public more about the technology and giving them what they want to see, which is we want to see this stuff get out there for the rest of humanity. So
yeah,
if you're open to that, maybe create a channel so that you can receive that kind of funding. Set yourself up some kind of crypto address or some kind of crypto wallet and give people a link to it so that they can anonymously donate to you if they should choose to. I mean, offer yourself an option to receive private donations that don't legally bind you so that this work can progress.
Another consideration might be, so there is Kickstarter, right? You can do a Kickstarter, and those are usually goal-based, right? Where you say we're going to produce X and we're going to do it by this date. And they usually offer some kind of a reward depending on the project, right? Like you'll get a discount on the first unit or whatever. There are other competitors to Kickstarter, and you might want to look this up. I would say anyone in this conference, There are probably 5 or 10 types of Kickstarter organizations out there. Kickstarter is the big one. There's 1 or 2 others that are pretty substantial. One of them is not goal-based. It's just basically support our project, and they've kind of got their own way of doing things.
Originally, years ago, we did Indiegogo,
That's the one I was thinking of.
and it was a total failure. A lot of work building the videos and all that. It's still out there. We asked for it to be deleted. Oh, we don't delete anything. So our all of our videos and stuff is still up on there. And but it was a total failure. We've talked about doing some funding. My real goal is to get a buyer for the technology to go to space. And that may be another year, another 2. I mean, we're getting by fine right now, but yeah, if we got additional funding, donations or whatever, we could definitely push the technology. I mean, you seriously, you almost need to go full-time on this project. I spend a lot of time working on it, but I also have other duties that I got to fulfill. And that's the only one. I basically teach 3 full-time faculty positions. I teach 75 semester hours a year, and I go all year round. So this is kind of like a vacation. I'll come back again if you want.
Yeah, no, I would love to. I'll say that right now. I'd love to have you come back again. We'll figure out when it works and
Sure. I mean,
yeah.
I love to talk about the technology, and I love to share the ideas and share the videos and things of that nature. Sometimes being able to explain it more, you get additional ideas, and I'm all for that. We got some new designs I'm really excited about pursuing, and it will, I believe, really revolutionize the amount of compression of the fabric of space. I got several designs, and they're on the drawing board. I had several. There was somebody was talking about particle entanglement, and we've actually got equations to build to initialize a particle entangled tunnel, and then put the warp bubble inside. That's all theoretical, but it's looking pretty good. I've spent about 3 years working on those equations. And our engineering equations that we can pre-predict the amount of power and the amount of compression of the fabric of space, or how many newtons does it produce, are looking pretty good as well. So the predictor for engineering is kind of critical in advancing the technology.
Wonderful. Well, so we are just at the top of the hour. So David, I think that's everything. Let me put it back on gallery view. Everyone, please give David Praise an enormous hand. Sir, I cannot thank you enough. If you'd like to come back, we'd absolutely love to have you come back. But
you bet. You bet.
Yeah, give it some thought, find a time that works. We'd love to have you come back. So again, I want to say thank you yet again. And